Hi everyone, my name is Peter. Welcome to this YouTube tutorial. Today we are discussing organic chemistry, and today's topic of interest is addition of water to alkenes or hydration of alkenes. So I have here before me a general formula of how alkenes react with water in presence of sulfuric acid to form an alcohol. So usually in these types of reactions, what you have to know that alkenes have a pi electrons, and these they are nucleophilic, so usually they have to react with an electrophile, and the resultant leads in formation of breaking of this double bond and addition of a new functional group. So therefore alkenes react with water in presence of sulfuric acid as a catalyst to form alcohols. So let us do this number one example and see how the mechanism of action of this reaction goes. So we know that water has an OH and hydrogen. So this hydrogen, or the hydrogen is water. Water is a weak acid, so therefore it's very hard for this hydrogen to be used to break this bond. So therefore we employ sulfuric acid and a very strong acid which dissociates and forms hydrogen ion and hydrogen sulfate ions. So therefore when these two species are reacting, so the hydrogen from sulfuric acid dissociates in this format, forming an hydrogen ion, which is an electrophile. So this electrophile is going to be attacked by the nucleophile from the pi electrons, leading to breaking of this bond in favor of the hydrogen sulfate, leading to formation of an intermediate species. Now, at this point, we have two things that can happen. So we can either form a minor product and a major product. So if we follow Markovnikov's rule that says that in short that whichever carbon has more hydrogen is added more hydrogens, we shall lead to formation of this, because this carbon has more hydrogens than this hydrogen, so it takes this incoming hydrogen from the sulfuric acid, leading to formation of this species, and we have a carbocation on the second carbon. Or if we don't follow Markovnikov's rule, which is anti-Markovnikov's, we shall have CH3, CH2, this hydrogen goes to this carbon, and we form a carbocation on this first carbon. So therefore, when we compare carbocation stability, secondary carbocations are more stable than primary carbocations. So therefore, this first species we have will lead to the formation of a major product, or that's what we call regioselectivity. So this will not form our product. So we are going to continue our mechanism with the first product, which is CH3, CH plus, CH3. So at this point, the water molecule, the oxygen uses its lone pair of electrons to attack the carbon, leading to formation of another intermediate species, which is CH3, CH. Now, this intermediate species, at this point, the base, either the hydrogen sulfate or water, comes to pick this hydrogen. So usually this will depend on your professor on what base to use. So therefore, in this example, I'm going to use the hydrogen sulfate base to pick up the hydrogen, or some books say that since we have water in plenty, the water picks up the base and still leads to formation of an hydronium, which is an acidic compound, and it further returns the hydrogen back to the sulfuric acid. Remember, it was our catalyst in this reaction. So if I use hydrogen sulfate as my base, it picks up this hydrogen and this bond breaks in favor of oxygen, and my final product is going to be CH3, CH, or H, CH3, which is 2-propanol plus sulfuric acid. Remember, this was our catalyst. So this is one of the mechanisms of how alkenes react with water in presence of sulfuric acid. So my next example I have here, cyclohexene reacting with water in presence of sulfuric acid. So mechanism of action, remember we say that the double bonds, the sulfuric acid breaks into hydrogen and hydrogen sulfate. It is a very strong acid, so that's why it dissociates completely. So the pi electrons attack the hydrogen, and this bond breaks in favor of the hydrogen sulfate, leading to formation of an intermediate species. So this hydrogen, when we form a Markov's rule, it will go on any of these carbons, since they are all secondary carbons, forms secondary carbocations. It doesn't matter which carbon you put it on, as long as it's within these two carbons. Then the water molecule comes and attacks this carbocation and leads in formation of another intermediate. So this is water. So this is when our base comes in, hydrogen sulfate, attacks the hydrogen, and the bond breaks in favor of oxygen. Then we form an alcohol, which is cyclohexanol. So remember, in organic chemistry, this is a cyclic structure, so it doesn't matter which side you put, it doesn't matter which carbocation you point on, they are still the same. So you can count from any number you want. So this can be carbon number 1, the same replaced with this, and the others. So it depends on what species or substitutions you have on. So that's why from this part I changed the carbocation to this side, so that to make it not so messy. So let us do our last example here. So we have this structure reacting with water in presence of sulfuric acid. The mechanism is still the same. So organic chemistry students, what they have to note is that they have to be visual. They have to know the product of the reaction before they do the mechanisms, because it really helps in understanding how most of the organic chemistry that you're going to encounter. So this leads to formation of this and a tertiary carbocation. So if this hydrogen goes to this carbon, then we shall not form a major product. We shall be not following Markov's. So this has more hydrogen, so it's added more hydrogens, hence we are following Markov's rule. So the water molecule the oxygen uses the lone pair of electron to attack this carbon, leading to formation of another species. So this is when our base, hydrogen sulfate, attacks this hydrogen, takes the hydrogen, and this bond breaks in favor of oxygen, and we form our final product as so this is methyl cyclohexanol. Because they are all on carbon number 1, I can decide you can put one cyclohexanol, but it's still the same as methyl cyclohexanol. So thank you very much for watching, and tune in next time as we discuss more of organic chemistry. In my next video, we shall be looking at how double bond species, that is alkenes, how they react with alcohols. Bye for now.